Hello everyone, Assalamu alaikum. Honorable Professor and viewers, welcome to my presentation in second International Postgraduate Conference on Mechanical Engineering organized by University Malaysia Pang. It's me, MD Mahmudul Hassan, and the other authors are MD Nazmus Saqib, Shahanul Islam, and Minarul Islam. Today, I would like to introduce you with a smart solution for low humidity problems using automatic ultrasonic humidifier. And the presentation outlines are introduction, objective, methodology, result and discussions, and conclusion. We know humidity has a substantial impact on biological and environmental factors. Improper relative humidity can create discomfort for individuals and affect several systems and apparatus. This study aims to develop a microcontroller-based system to identify and eliminate such low humidity problems. A control system is implemented to generate air humidity according to the need to decide whether the unit is working. A humidifier is developed using vaporizing ultrasound, which can still be considered the automatic ultrasonic humidifier. Introduction. The humidity is the concentration of water vapor present in the air. Air conditioning also decreases the temperature and reduces humidity, increasing discomfort in the summer. Effect of low humidity on the human body is shown in figure 1. In figure 1 we can see the problems affecting on human body, like catching a cold or infection. It may be dry or itchy skin and may be damaging our house wood, siding or paint. The objective of this research is to develop a microcontroller-based system to detect humidity in the weather automatically. Now we will discuss about the methodology. The proposed control system workflow of a humidifier is shown in figure 2. In that figure we see we have to input the setting value and the sensor will read the humidity, and by the control system will define whether the humidity lower than the setting value. If it is yes, then our humidifier will be activated, but if it is no, then the device will not be activated and the sensor will read the humidity continuously. In figure 3 we see the proposed experimental system setup of the humidifier control system. We can find a keyboard and a display. That keyboard is used to put the setting value, and the display is for displaying the humidity. And we see a breadboard and Arduino. These are used to make the control system, and we may find a humidity sensor in the figure 3, and there is also an ultrasonic transducer. Now we will discuss about the results. The data for calibration of temperature and humidity with and without sensor is shown in table 1. We have taken our data in 3 different days in April and 3 different days in May at different times, and we have found there was a little bit difference between actual relative humidity and our sensor reading relative humidity. In figure 4 we can find the difference between actual and sensor reading of relative humidity. Here the black dotted curve is for actual relative humidity and the red dotted curve is for sensor reading relative humidity, and we can see our sensor reading relative humidity a little bit smaller than the actual relative humidity. In table 2, we can see data for humidifier activity with respect to setting humidity. We have taken our data 3 different days in April and 4 different days in May. Our set value was 60, whether the sensor reading was 54.8, 54 and 57.3 in 10th April, and we have found our humidifier was activated in these cases because the sensor reading was lower than our setting value. But in 17th April we found that whether the sensor reading was greater than our setting value, then the humidifier was not activated, and we have found the same case in the other days, 2nd April, 3rd May, 10th May, 16th May and 21st May. If the sensor reading was greater than the setting value, then the humidifier was not activated. It was only activated when the sensor reading was less than our setting value. Conclusion: the system helps to increase the amount of humidity inside predetermined significant stress during the winter, and then when the humidity is smaller than enough, the system is often useful. A country like Bangladesh recorded a higher value of relative humidity rather than standard. Our study is appropriate in the winter season or areas where humidity is lower than that of standard. Using sprinklers rather than atomizers and incorporating features for continuous operation using specific temperature and humidity sensors can be improved. Acknowledgement: this work is supported by Khulna University of Engineering and Technology. The authors would also like to thank Faculty of Electrical and Electronics Engineering Technology, University Malaysia Pang, for providing the facilities to complete this work.